For those of you who have been fans of my channel, you might all know that I have an interest in software preservation and history. Well, as of late, I've been interested in digging into a program that nearly everyone has used at one point or another, Microsoft Word. While people may have differing opinions about Word, it's hard to argue that it hasn't had a tremendous impact in not only just computing, but the digital office space as a whole. Unlike many of the titans of the early 90s, such as WordPerfect, the source code to an early version of Word is legally available. In 2014, Microsoft donated the source code of Word for Windows version 1.1a, or WinWord, to the Computer History Museum. The museum in turn has made it available for download on their website. This version of Word was originally released in 1989 for Windows 2.1 and 3.0, and thus provides an interesting insight into the early days of Microsoft. That being said, although seemingly simple on the surface, the Word source archives contained more than a few surprises as I dug into it. It also has the distinction of being one of the few examples of a Microsoft product from an era when OS/2 was considered to be the future of computing. Yes, there was in fact an era when even Microsoft didn't think Windows had a future. Strap yourself in, folks, because this is going to be one heck of a journey back to 1989. As always, this is your host NCommander, and today I'm going to suffer in pain as we attempt to compile Word for Windows from OS/2. Okay, that probably sounded a lot more epic in my head, but let's get to it. At this point, I'm guessing most of you have one of two questions. What is OS/2, or why OS/2? Let's start with the what first. OS/2 is the intended replacement for DOS as a product of the ultimately ill-fated venture between IBM and Microsoft. Originally announced in 1987, OS/2 promised to bring multitasking to the masses and usher in an era of graphical applications with its presentation manager replacing the clunky command line. While graphical user interfaces, or GUIs, already existed at this point, for the most part they were still fairly niche. OS/2 promised to bring the GUI mainstream to IBM-compatible machines. For the latter half of the 80s and early 90s, OS/2 was seen as the future of computing. For a variety of reasons, though, this future didn't come to pass. In truth, the reasons for this are so long, I could dedicate a series of videos talking about the flaws and failures of OS/2 from both a technical and marketing standpoint. That being said, OS/2 does have real improvements over DOS and the early versions of Windows. While it wasn't a true market success, OS/2 did find a niche as a host platform for software development. This is a good moment to explain why developing on top of DOS can be somewhat painful. Due to the fact that DOS runs in real mode, it is subject to several limitations, such as the infamous 640 kilobyte barrier. This can best be seen if I simply try to build WinWord from DOS. As shipped from Microsoft, the DOS build tools require the 386 Max Memory Manager. On system startup, we can see that we have 8 megabytes of memory available. However, if I attempt to build WinWord without a very specific setup, then the build will fail running out of conventional memory. This is, in part, due to the inherent limitations of real mode applications. While these sorts of problems can be kludged around through the use of DOS extenders, the long and short of it is that it's easier to use a more capable environment. This brings us to the why OS/2 part of the equation. For this time period, it's likely that most of the development was done on top of OS/2, and I wanted to get an idea of what a Microsoft engineer might have experienced. While I would love to say I had no issue in getting this to work, my first attempt at booting off the installed disk immediately crashed with a trap error. While it's not uncommon for older operating systems to go belly up on newer hardware, the 16-bit versions of OS/2 are notoriously bad about this. In practical terms, any system faster than a 386 will cause the system to crash on boot. While there are unofficial patches to fix this, for the sake of authenticity, I decided to simply emulate a 33 MHz 386 processor with 8 MB of RAM. It would have been a truly monstrous system for the time period. I would also come to regret that decision. With an emulated 386 in hand, I successfully made it to the boot splash screen. Overall, installation is fairly straightforward, although one thing to note is OS/2's very small selection of drivers. Due to this, I was stuck in a low-resolution 16-color mode throughout this video. After a few basic questions, the installation grinded away for a while and then prompted me to reboot. After the system came back up, we're greeted with what can only be described as the blandest desktop known to mankind. It wouldn't surprise me at all to learn that there was a committee at IBM to keep things as bland as possible. Aside from some system utilities, the only application of note is the system text editor known as E. There are no games or other applets to be found here. This is compounded by the distinct lack of native OS/2 software, especially for these early versions. In addition, for those familiar with early Windows, you might notice a striking resemblance to the then upcoming Windows 3.0 in both look and feel. This is one of the last vestiges of the IBM-Microsoft partnership. Besides the rather bland desktop, a single icon exists in the corner labeled DAWs. This icon is OS/2 1.2's feeble attempt at supporting DAWs applications. Until OS/2 2.0 released in 1992, the system was only capable of running one DAWs application at a time in full screen mode. Furthermore, this was compounded by poor performance and a lack of sandboxing. That meant that a misbehaving DAWs application could hang the entire system. Of course, we're here to compile Word from scratch and not just grok at old operating systems. The next question is how we're going to load the WinWord source code onto OS/2. While there are numerous ways to solve this issue, such as making a multi-part zip archive, I decided to go with what can be described as the lazy option. Due to the virtual nature of our OS/2 machine, we can simply mount a hard drive under Linux and copy the files over. A few commands later and we're ready to restart OS/2. With the files copied over, we can now start examining the download from the Computer History Museum. The first thing, unfortunately, I need to talk about is the license. The source code for Word for Windows is under a very restrictive license that essentially limits the context in which I can talk about it. Primarily, I can't show or publish anything beyond short excerpts of code, nor can I publish binaries. So instead of the usual, here's a GitHub link with all my work, for this one, you're going to have to follow along at home and take my word for it. Secondly, the license also requires that any projects, such as this video, be non-commercial in nature. To comply with that requirement, I pledge not to monetize this video. With the legal mumbo-jumbo out of the way, let's get down to it. Most of the code for Word is located in the Opus folder, which was the codename for Word for Windows. As previously alluded to, a full set of tools and compiler binaries are included for use on both DAWs and OS/2. Interestingly, many Opus tools are what are known as family mode binaries. As the name suggests, family mode binaries, also known as FAT binaries, are intended to work on both OS/2 and DAWs, similar to how Windows binaries can include an optional DAWs component. We can easily see this by using the DAWs window to run make opus. Notice that it runs the same in either environment. A closer examination of the tools begin to show unexpected findings. At the time, Microsoft's primary toolchain was Microsoft C and C++, which eventually evolved to become the modern-day Visual C++. However, the toolchain included within Word for Windows is not Microsoft C. Instead, it's a custom tool called CSL. After a closer examination, it's clear that CSL and many of the tools included in the Opus archive were entirely internal to Microsoft. What is truly unique here is that this is not a normal C compiler. Instead, it's what's known as a P-code compiler. Instead of compiling to native code, it compiles to a special type of bytecode that Microsoft calls the embedded language, or EL. Instead of running Word directly, the WinWord executable loads a special interpreter which then reads the bytecode and converts it to machine code at runtime. In modern terms, Word 1.1a can be seen as an early predecessor to Microsoft's later .NET or Sun's Java runtime environment, which would come years later. According to the comments in the source code, EL was also used in early versions of Excel, and some research suggests it was also used in Multiplan. There is relatively little information about Microsoft's use of P-code, but I have my suspicions on why they used it. Before we get into that though, it would behoove us to actually attempt to compile Word for Windows. I hinted at it earlier, but compilation is handled by the Make Opus tool, which has a large myriad of options and settings. The built-in help of Make Opus combined with some loose notes I found on the internet gave me the general idea of what I needed to do. To make a long story short, Make Opus needs a special configuration file to define the build environment. Helpfully, Microsoft included two example files, one for release builds and another for debug builds. I started with the release settings file and edited it to match our setup. Beyond that, I also found I had to add the tools directory to the path and create a temp directory. On OS/2, environmental variables are set in config.sys. This is different from DAWs, which instead uses autoexec.bat for this purpose. In many ways, using OS/2, especially from a programming perspective, is like using a bizarro version of DOS or Windows, with many things being similar and yet different at the same time. Before I get too philosophical though, we're ready to try this after a reboot. Unfortunately, it didn't take long for errors to go screaming by. Fortunately, the error is obvious by reading the back scroll. MakeObus is trying to load the DOS version of the tools. This turns out to be a relatively easy fix. In MakeObus's help, it has a full list of options. The relevant one here is called MakeOS2, which tells MakeObus to use the OS2 version of the tools. I'm not entirely sure why this option needs to exist. One would think that MakeObus would simply load the correct tools based on its environment. Regardless, with MakeOS2 added, we can now see that the build is finally starting. Of course, it would be far too easy if that's all it took to build Word. After only a few minutes, a new string of build errors crop up, this time relating to an application called DE. From context, DE appears to be a tool to compile UI elements. In this case, we're getting an OS2 sys error. Information and system errors under OS2 always start with sys followed by a number. By typing help sys 0197, we can get both the cause and the fix of the exact failure. In this case, DE needs an option called IOPL to be set to true in config.sys. The IOPL option, short for IO privilege level, controls the use of what are known as IOPL segments, and the ability to run code in a special processor mode known as Ring 2. I'm not entirely sure why a compiler needs this, but after a reboot, the DE utility is now working. So the question is, will it build yet? The answer, sadly, is no. With DE fixed, it's only a matter of time before we get another failure with another error message. In this case, it's a rather unclear message that simply states the program could not be run. Help says we're running a wrong mode application. In other words, MakeObus is trying to use a DOS utility under OS2 mode. By examining the MakeObus tool and the build directory, I eventually worked out that MakeObus writes a script called mo2.cmd. This script lists every command that will be run to complete the build. Through a process of trial and error, I eventually managed to isolate the problem, the egrep command. For those familiar with Linux or almost any Unix-like operating system, egrep might seem familiar. It is a utility to search the contents of files via regular expression. egrep is not provided by OS2, instead it's one of the utilities included with the WinWord source code. More egregiously, its closely related cousins, grep and fgrep, work just fine. Switching back to our Linux host system, running the file command reveals the reason why. egrep is not a family mode executable. Only a DOS version is provided. True enough, if we use the DOS window, we can also get egrep to work. However, this presents a problem. On OS2, DOS and OS2 binaries can only be used within their respective environments. Without an OS2 version of egrep, I was stuck, although I wasn't necessarily out of luck. egrep is a fairly standardized utility after all. Looking at the grep and fgrep binaries I had, Microsoft had likely ported egrep from their Xenix operating system to DOS and OS2. Since there were free and open source implementations of egrep available, there was a good chance I could find or compile a replacement. It was at this point where a member of the Virtually Fun Discord group pointed me at the GNU-ish project. The GNU-ish project had ported several GNU utilities to DOS and early OS2, including a copy of egrep that I confirmed worked properly under OS2 1.2. Further testing showed that it worked identically to the DOS version of the command. In short, after renaming a few files, we're back in business. So, with that hurdle passed, the question now is, would it build? As it turned out, compilation dragged on, primarily due to the underlying 33 MHz 386 emulation. It took several hours before I got my answer, but in this case, perseverance is a blessing, and I was finally greeted with the magical line of "Make complete." A quick look in the build directory shows that I indeed have a copy of winword.exe waiting for me. The question is now, does it work? For eagle-eyed viewers, you may have noticed that the WinWord binary was marked, as we previously saw in Hello World for Windows 1.0 to prevent compatibility warnings. We're going to test this binary in a moment, but I do want to address the implied elephant in the room. Now, those familiar with OS2, and especially the later versions, may be wondering why I have not shown WinOS2 up until this point. For those of you less familiar with OS2, you might be wondering, isn't it having to develop on OS2 and then test on Windows kinda a pain? Well, let's answer those questions one at a time. Later versions of OS2 were rather famously marketed as a better DOS than DOS and a better Windows than Windows, and versions 2.0 and later can run 16-bit Windows applications without issue. However, this is OS2 1.2 and there is no Windows support built into this version. That's not to say you can't add it. As it turns out, you can simply install a normal copy of Windows 3.0 directly into the DOS box on OS2. This is in fact something officially supported by Microsoft and is even mentioned in the README file. After installation, simply type win and boom! Welcome to Windows 3.0 running under OS2. In truth, this is little more than a novelty than anything actually useful. This is due to the fact that Windows is stuck running in real mode, meaning that most Windows 3.0 and 3.1 applications simply won't work. Furthermore, trying to open a command line or DOS application simply says that this feature is not available under OS2. However, we can run our compiled version of Word without issue. At this point, I think we can safely say, mission accomplished. However, there's more to talk about here than just compiling Word. Through the course of this project, I found myself with quite a few more questions than answers. For example, let's take a brief look at the native OS2 version of Word 1.1. At a glance, it looks identical to the Windows version we just compiled. Is this the same codebase or is there something else going on? As I dug deeper, I began to find more and more questions as I went on. For instance, why is Word compiled to bytecode, and just what other mysteries did I find in this codebase? What is the relationship between Word for Windows and the myriad of other versions that existed at that time? And finally, the question you've probably all been wondering, does it work on Windows 10? Unfortunately, those questions and more will have to wait until next time because we're out of time on this video. Next time, we're going to be digging into the lineage of Word and the secrets I found hidden in this codebase. If you'd like to see that video when it becomes available, please subscribe and leave a like. It really does make a huge difference for the channel. Beyond that, as usual, I can be found on Twitter and Discord if you want to follow my adventures in real time. Until the next time, this is NCommander, signing off.